Hello and welcome to this video on matrix modeling with 2x2 matrices. There is an accompanying handout which includes this starter question. Please have a go at it. Answers will be on the next slide. Please pause the video. And here are the answers. Notice that we were looking for variables J and A in the third question, and that will make sense when we look at our modeling. So, the population of beavers in the southwest of Djibouti consists of juveniles J and adults A. Juvenile beavers do not reproduce. In a study, the numbers of juvenile and adult beavers were estimated at the start of each year, and a model for the population satisfies the matrix system as shown there, where Jn and An are the respective numbers of juvenile and adult beavers n years after the start of the study. And in our first question, we're being asked to interpret the meaning of each of the elements of the matrix, 0.65, 0.12, 0.1 and 0.8, in the context of the model. So Jn plus 1 is the number of juveniles the year after the year when there are Jn juveniles. And as an equation, Jn plus 1 is given by 0.65 times Jn plus 0.12 times An. So what do the 0.65 and the 0.12 mean? Well, the 0.65 Jn must be the juveniles in year n that are still juveniles in year n plus 1, whereas the 0.12 is an increase in juveniles based upon the number of adults, so it must be adults that are reproducing because they're not turning into juveniles. So 12% of the number of adults is an increase in the number of juveniles, and 0.65 is a 65% of the juveniles who remain as juveniles from one year to the next. Looking at the 0.1 and the 0.8, that comes from the equation An plus 1 is equal to 0.1 Jn plus 0.8 An. So 0.1, 10% of the adults are coming from juveniles. So they were juveniles, so it's 0.1 times Jn. They were juveniles in year n, but they've turned into adults in year n plus 1. And the 0.8, that'll be 80% of the adults An staying as adults from one year to the next. According to the model, in January 2023, the number of juvenile beavers was 3,810 and the number of adult beavers was 10,160. Our second question is as follows. Use the model to estimate the number of juvenile beavers and the number of adult beavers in January 2024. Well, 2024 is obviously the year after 2023. So in order to find the number of juveniles and adults in 2024, we just need to use our model, multiply our matrix by the number of juveniles and adults in 2023, which were 3,810 and 10,160. So using matrix multiplication, we get 3695.7, which is approximately 3696, and 8,509 adults. Question 3 asks us to use the model to estimate the number of juvenile beavers and the number of adult beavers when the study started in January 2022. So in this case, of course, the year 2022 is the year before 2023. So rather than multiplying our matrix by the number of juveniles and adults in 2023, we actually want to use the inverse matrix to go backwards. So if we times our inverse matrix by 3,810 and 10,160, and the inverse matrix is given there by 250 over 127, etc., we get 3,600 juveniles and 12,250 adults. And finally, question 4. A study of the population revealed that adult beavers stop reproducing once they reach the age of 8 years. Refine the matrix system for the model to reflect this information, giving a reason for your answer, and there is no need to estimate any unknown values for the refined model, but any known values should be made clear. So in essence, what we're being asked to do here is to create a 3x3 matrix. So we still have our juveniles, but our adults are being divided into two groups, one of which is age 7 or below and can reproduce, and one of which is age 8 or above and cannot reproduce anymore. So my answer is A, B, 0, 0.1, C, 0, 0, D, E, and I need to explain the 0, 0.1, 0, and 0. So let's look at each element. Jn plus 1 is the sum of, firstly, the fraction a of juveniles that remain, which we don't know. 2, the fraction b of the number of adults from the previous year as a result of reproduction. And 3, 0, because beavers aged 8 or more have stopped reproducing and therefore have not contributed to the number of juveniles. So the 0 is the only number in the top row that we actually know, and it's because adults aged 8 and above cannot reproduce. The second row, an plus 1. An plus 1 is the sum of, firstly, the 10% of adults that are from juveniles that have grown into adults, which we knew from before. Secondly, the fraction c of the adults that remain as adults from one year to the next, which we don't know. And thirdly, 0, because beavers aged 8 or more cannot become adults aged 7 or below. Obviously, you can't go get younger. And then finally, our third row, for a being greater or equal to 8, that's the sum of, firstly, 0 juveniles going straight to the age of 8 rather than staying as juveniles or becoming adults. So that explains the 0 there. Secondly, the fraction d of adults becoming age 8. And thirdly, the fraction e of beavers aged 8 or more who are still alive. So that explains where our 0, 0.1 and our other two zeros come from. We don't need to explain the other elements. So to finish off, I would like you to have a go at this exam question. It's available on a separate PowerPoint. It's longer than this. There's 2 slides of the question and another PowerPoint with the answers on it. It's from the Core Further Maths AS Exam 2019, question 10, about chimpanzees. Thank you for listening.